Hi class, it's Bill Berry back with another week 3 lesson from our Java 2 class. Today we are focusing on generics. This is a cool topic without which we couldn't really make it that far in this course, something that we really need. You've used these before, but you haven't really necessarily explored how to write them or the real in-depth ways in which they work. So it's an exciting topic, an important topic, I think a pretty cool one. So let us jump in and start with generics. So let's take an example here. Let us start first with some code. Let us start with this particular project here. Let's say, as a starting point, that you wanted to make a little class called ID Box, and the idea is that this class will help you tag or put an ID on whatever the contents are of that box. It's going to be sort of a little wrapper where it lets you give an ID to whatever it is that you want to put in this box as contents. Now we're going to start with integer, as we often do when talking about data structures, just so we can understand how to transform it from this to something else. So the idea would be when you go to create one of these things, you have to give it an ID, and then you have to give it whatever the contents are, right? So in this case, you got a contents of the box. It's some integer that for whatever reason the user passes you, and you want to tag it with some sort of ID, maybe so that you can sort them, maybe so that you can group them together with like ones, however it is that you want to work with this. So obviously those two pieces of data come in, you have to set those contents. We can do preconditions if we want. So it's really not a very well-developed idea, but it's an idea that will get us started. So let's say that you look at this and you go, wow, that's useful. I can see where I might want to do that. But what if I wanted to put something else here besides the integer, right? What instead of an integer, what if I do a double? Well, that's not too hard. I can certainly change all the ints to doubles when it comes to the contents, and that would be fine. What about for some other data types? Well, that's fine. You could certainly make and copy and paste this and make an ID box int and an ID box double and an ID box char, but eventually you're going to get really tired of copying and pasting all this code, and 90% of the code is identical, right? But worse, think of all the objects in the world, because it gets much more interesting when the contents of this box are not primitives at all, but rather it's an object reference. So you want to make an ID box to handle a student or a person or a car or an airline seat, right? Whatever it is, you want to have this be an object reference. Well, again, you could get clever and say, wow, I could just make one of these for each one. I can have an ID box student and an ID box vehicle or an ID box airline seat. Well, yeah, but again, this is going to get really tiring copying and pasting and ending up with the exact same code with just a few data types switched out. Does everyone see that? It's really this data type that gets switched out everywhere, right? Int, all of the places where we're dealing with contents, we would have to switch that out for something new. So that doesn't really seem like a sustainable approach, does it? It seems like there should be some better way. So maybe being a clever person, you say, what if I just, since I know now that object is the super grandparent class of everything that's an object, what if I just used object, right? What if I just said, hey, you pass me an object and I will store it? Right? That sounds like that could be a way forward, right? That could be a possibility. But what's wrong with that? What's the bad news about using object in this way? Well, the worst news of it is that you will now allow anything on the planet. Right? You will literally allow anything that might come in here, and you don't have any way to know what those things are, right? So they can give you whatever type that they want, and you store it all. But what happens if you want to go do something like to compare the two things, right? How can you compare two objects to each other if you don't even know the type? Mostly that's not even going to work, right? You can't really pass an object and have it expect to compare to another object in any successful way, right? That's not how compare to works. And also, when it comes to compiling, you're going to have to do a lot of checking at runtime especially. You're going to have to do a lot of checking to say if this object is of this type, is it of that type? You're going to forever be fighting with these things, and you're going to lose any sense of type safety. Because probably in any given application, what you want to store here in this box, you want to store contents that are the same because you want to compare them to each other and you want to organize them in some way. You really want better type safety than this, right? That's kind of a poor way to get it. It's too far up the object hierarchy. Really, object is not going to solve our problem here, right? So what we really need is a different approach, right? We need a whole different thing. So I'm going to just copy this. I'm going to copy this whole thing, and then I'm going to create a new class just called ID box. And I'm going to paste the code into that, and then we need to sort of figure out a new plan. Right? So I'm going to take off the int, and I'm going to take off the int. And so for the moment, that is as fine a start as any. So now what we need to do is see what can we learn? What new thing do we have that will solve this problem? And the answer to that is we need a generic. Why? Because a generic will provide type safety. It'll guarantee that the contents of the box are always the exact type that we instantiate the thing for, right? The type of the box, the contents of the box are always going to be the proper thing based on the type that we specify, and better yet, all of that stuff is going to be checked at compile time. So the client code, anytime you're using this code or anybody else is, the client will not even be able to compile if they're trying to use these things in types that don't match. If you're trying to store integers in one and students in another one, you know that the compiler is going to catch that and it's going to keep that from happening. So you're going to get type safety and you're going to get a lot of other goodness if you do this. So instead of simply saying ID box, the magic of generics is you put here some angle brackets, right? You put an angle bracket. Inside the angle bracket, you put one of a few letters that are typical. You can actually use any letter you like, but there are a couple letters that are typical. T represents type, right? If it's just a generic type, you can put T there. Another one, if you're making a collection, E for element. And if you're using maps, there are some other ones that are common. It doesn't really matter, right? You just have to make sure you use this consistently. What this says is, much like you've seen with an array list, hey, when you instantiate one of these things, when you create an ID box, you have to tell it what the type parameter is. Right? So when you declare one of these things, instantiate one, you've got to say something that makes sense in the angle brackets. Right? Now, in this case, T is a placeholder, right? You can almost think of it as like a mail merge, that when they instantiate, at that moment, whatever type they say becomes the letter T here, right? So one thing that we need to go through and do here to make this really work is that we have to go figure out where we need to use T in our code down here. Right? Instead of a data type, right? Instead of one of the other data types, we're going to use T. Now, do we use it for the ID? Well, no, because ID is just an integer, right? That's always an integer. But in terms of the contents, what is that going to be? Well, the contents is always going to be a reference to one of the objects of that type. So we're going to replace that, instead of with a hard-coded name, we're going to put that T, which is going to get substituted, right? It's going to get substituted when the user instantiates this thing, right? It's going to do a replacement, and everywhere where it says T, right, it's going to replace it with whatever the type is that is provided at the time of instantiation. All right, so that's the first one. Where are the rest of them? Are there some more? Well, let's see. Integer, no, that's the ID, so that's good. But now here, instead of int, I need to do T, right, for contents. How about in setting? Well, setting the ID, fine. Setting the contents, oh yeah, that's going to be a T as well, right? How about getting the contents? That's going to return a T as well, right? So what we've done now is, with that simple little substitution, we have created a class that takes a type parameter. We've created a generic class that says anything you pass to me, Objects, right? These are going to be class names, not primitives, just like array lists. Don't work with primitives. Don't work with, ints and double lowercase d. They have to work with wrapper types. Fine, we understand that. But these work with whatever you say you want to pass into it, right? Whatever you say. And it will make the box, it will keep the contents, and all of the stuff in here is going to work exactly as we'd expect. So, wow, that's kind of a big deal. So how can we go test that, right? Because now I have ID box T here. How can we make use of these things to see how it works? Well, let's go down here and let's create a, let's see, ID box, and let's put a string in it, right? Equals new ID, and remember all of these things you're going to put now type parameters. The only thing that's different is over here on the right side of the equals you can get away with this called diamond notation because it will infer it from over here, right? I would get used to just typing it anyway, it won't hurt you any. And then what am I going to put in? Well, I'm going to give it an ID number 13 and I'm going to give it a string. So my string is going to say hello. Right? Whatever. Put it 1, put whatever number you want. Now notice this compiles beautifully, right? This compiles beautifully. Now, what doesn't compile? Well, we're going to get strong typing. So let me go over here and show you that strong typing is going to be very helpful. What if I tried to do this and pass in a, let's say a wrapper type? How about integer? And I'm saying, 2-35. Okay. Notice that the compile won't even succeed because it's going to say, hey, I can't do that, right? It doesn't make sense to put an ID string box reference and point it to an ID box integer. Those things are incompatible. It doesn't work. So what you've seen here is that at compile time, now the strong typing can really keep us in line and only using strings when we meant to do strings. And of course, if we make an array of those, the only thing that comes in then is ID box strings, nothing else. So they are strongly typed. Now, you can certainly create them of different types, right? I can do this and then say new ID box integer, of course, right, using a wrapper type, and then I can give it some number and I can give it something that can be turned into an integer, and that's great. But how about this? Box 3 equals box 4, right? Again, incompatible types. So strong typing is kept here very, very nicely, right? Very nicely. I can compare those things, and they are perfectly tightly, tightly bound, perfectly typed and safely typed. Now let me do this just for fun. Let's do box 4 here, just so we can see. And let's put this, and let's put halo in there, right? Now watch what I can do here. Box 3 dot get, right? Contents dot. Now what happens when I put a period here and I do autocomplete? Wait, where does all this stuff come from? All this stuff comes from the string data type. It's so strongly typed that it knows, hey, the thing that came back from get contents, it's a string, right? So I can do whatever I want, right? I can do this kind of thing, and I can print the answer to that. System.out.println box 3 equal to box 4, right? And when I run this thing, it's going to compare those two things and say which one is bigger or smaller, or I can certainly do equals, right? So the strong typing is literally all the way through, threaded all the way through this code. That's pretty amazing, right? That's pretty amazing. So the generics really provide us a great way to keep our code extremely flexible, right? To write code that's very flexible and that can work with any type that we pass in at the time of instantiation, right? At the time of creating these static references or these dynamic references, right? Dynamic types, either one, right? Those things, the strong typing is going to hold all the way through. And when you grab out those contents, it knows darn well that that's a string. So you can act on all of these things as strings. No checking of types, no worrying about whether it's the right type. oh, I promise it's the right type, right? In box 3 and box 4 has to be strings. So generics are extremely useful in that way. When we look at array list code, right, when we move from looking at array list int or int list or however you want to say it, when we move into working with real array lists and see how they're written more or less in Java, this is going to be a very critical piece, right? Because array lists want to work with whatever type you tell them to work with, and they work with these things exactly through this mechanism of generics. So that's a great start to our understanding. It's a super simple little program, but it's a great start at our understanding of how generics work. Now, there are a lot of interesting things that we're going to look at here, right? We're going to, the slide sort of walked us through the thing that we talked about there, and then we're going to come back and we're going to look at some of the limitations and we're going to explore a little bit deeper, but that's a great start for just understanding the basics of how they work and how you write them in a super simple way. So let's stop the video here and we'll continue in another one to get into the depth. And I appreciate you watching this video. Hope you're learning something fun. Let me know in the comments. Thanks.